Hi, my name is Chandra Carr. I am presenting for my mock app, Bridge Health, and this is the diabetes patient readmission risk scoring presented for CIS 508. So to talk about the problem a little bit, the major issue is that hospital readmissions for diabetic patients end up costing hospitals over 41 billion annually. And there's a significant number of patients that are readmitted after they've left the hospital emergency room or the hospital for a stay. And this takes up a lot of resources. And this requires us to kind of look at why this is happening, look at kind of why we're missing these high risk patients and how can we prioritize the risk of readmittance. And this leads us to kind of ask which patients are needing more follow-up before they leave the hospital and which patients will need more care after they leave the hospital. Um, we don't want to, overrun the hospital system by checking every patient. They're already busy and overworked. So we want to reduce as much of the resource waste as possible while still not missing the patients that need to be seen. So for this task, I decided to target, obviously, readmission as a binary classification, and I used the UCI machine learning repository diabetes data from 1999 to 2008. This had over 100,000 rows in it. Originally, I targeted for looking at just within a 30-day readmission. However, this was not a usable score with this particular data set. So I decided to go ahead and look at any readmission. However, for all of the framing, I stuck with the 30-day medical standards just because our current data and resources kind of tells us that we know that the majority of patients that have diabetes are being readmitted within those 30 days. So what I was looking for was the F1 score. I really wanted to make sure that I was balancing that delicate balance between not overwhelming the hospitals with cases that may not be as needy as others, and making sure that I was catching as many high-risk patients as possible. The secondary was the ROC-OC score, partially because of the imbalance in the data. So after cleaning the data, I got to about 70,000 encounters, except for one of the data sets I had to shrink down to 12,000, the SVM, or support vector machine, just to kind of allow it to have a reasonable running time. Otherwise, it was taking 5+ hours to run. So for this particular case, I needed a shorter training time. One of the challenges that I faced originally was that when I had originally cleaned the data, I had removed all null values, and that took me down from over 1,000 rows to just under 300 rows. And so that wasn't going to work. So I decided to go with, if there was 40% of the data missing, then I would go ahead and eliminate it. Otherwise, that data was kept. So out of the 9 total models that I trained, I was looking for that high F1 score. This was definitely a more challenging data set because I was not seeing, the scores that I was expecting in the 70s and 80s. However, for a medical model, this works pretty well as a real world model. And just kind of looking through the different ones, excuse me, this definitely worked best for the balanced metrics. So the winner was the XG Boost. That gave me the best scoring for precision and recall. And it still had good discrimination for ROC-OC, and it was fast to train. So I went ahead and moved forward with that model. So this is a quick look at the app that I created using this machine learning model. It features the real-time risk calculations, so hospitals and staff can kind of see patient risk immediately before patients are discharged. It gives a visual kind of color-coded system so that Um, they will know immediately whether or not a patient is at risk. It's easy to understand and doesn't require a lot of focus or concentration for busy hospitals. So some of the details, I used Python for coding and Streamlit for deployment. I did this through GitHub, and some of the data entry fields that I used for this determination was demographics, clinical diagnoses, medications, prior ER and hospital visits, as well as the current stay. So let's go ahead and take a look at the app. All right, welcome to the GlucoBridge Health app for risk scoring for patients. So as you can see, I've got some pre-filled information in here. And if we hit calculate risk score, this particular patient has a low risk level of readmission within 30 days. So it still gives some key factors that contribute to this particular score. It also gives the standard next steps for discharge. So let's take a look at a patient who is going to be requiring a little bit more care here. We'll go ahead and change some of these numbers. This particular patient has been in the hospital for a while, and they are definitely not feeling well. Yep. And they came as an emergency, and they've had quite a few visits in the past uh, year. And their medications changed while they were staying at the hospital, and their insulin had to go up. And this section is for diagnosis codes. These right here, 250 is the diabetes code. Oh, this particular patient has a 41% 30-day readmission risk. And so the key contributing factors here, there's quite a few things that contributed to their stay. And for this particular patient, it's recommended that they visit a diabetes educator before their discharge and make sure that they have a follow-up with their primary care within 7 days and that their scores are communicated to their primary care doctor. Go ahead and um, uh, go a little bit about the model here. So this is just a page kind of about the model behind this particular web page. So we're looking at excuse me, a hyperparameter tuning, which was quite extensive. I ran quite a few different model runs, working on getting this score up from where it originally was in the low 20s and 30s. And so there was a lot of hyperparameter tuning as well as feature engineering. I did originally use SMOTE to deal with the imbalance in data. Unfortunately, this caused some issues where every single patient was being flagged as high risk. So I went back and actually changed that to a different handling. Um, there was also some, like I mentioned before, some of the time training issues that came up where some of the models were taking quite a long time to run and were not giving me the improvement in scores that would have allowed for that to continue. So some of those I did have to cut a little bit short. Um, so one of the other things that I had to do was make adjustments to the code to kind of change the threshold a bit for the model to predict correctly whether a patient needed to be readmitted or not. Some of those scores are listed here as to what we consider a low, medium, or high risk tier. And then this is again the model performance, and we'll actually go over that in the Databricks section as well. Oh, I need to sign in again. While that's signing in, I will show you my README. So this again is a lot of the information that was on the page itself. And through some of the slides, just talks about some of the application features, some of the safeguards. I do have a disclaimer on here that this is a school project and not for medical advice. Um, Again, for my XGBoost, some of the information we'll go over in the data bricks here again. And then I also have kind of a guide as to reproduction on how I came up with this model and the app, and some of the kind of more details about how I got to this particular model. And let's see, some of the issues that I faced that we've discussed, um, and some of the ethical considerations. One of the things with this particular data set is the fact that because of the timeline that this was logged from, this is not an up-to-date model. We would need to use current data for this to be an accurate model. Um, this is also still missing a lot of readmissions. Part of that is from the data set just being kind of where it's at, but it is still kind of missing patients that we would consider critical. So I would go back and kind of rework the like recollect data in order to kind of improve this model to put it into actual flow. Okay, so let's go ahead and take a look at the experiments here. Gonna be slow today. There we go. All right, so here is the diabetes pipeline. Here's what that's waiting. Okay. So as you can see, I went through quite a few runs. There are, I think, over 500 here. Not all of them logged the metrics that I was looking for. So I focused on only the ones that provided the accuracy and F1 scores and test precision. So you can see I've got the XG Boost and Decision Tree. These were my top performing models, um, as well as ensemble voting. Ensemble was kind of interesting to use because I honestly expected it to give me better results than it did. And I had to play around with the voting quite a bit in order to get something that was a reasonable F1 score. Um, and here's the SVM that gave me so much trouble that I had to parse down to 12,000 rows just to get it to run in a reasonable amount of time. I had tried running it with 80,000, and that was still taking hours. Also the gradient boosting. I did find it interesting that I was like, as I was going through and doing some of these runs and so forth, just actually getting to see how some of the different classifications were going. Um, and then I got my neural networks and my logistic regressions down here and naive Bayes. I was honestly kind of surprised that this one was so low. And then I will take you back to our presentation and go more. I just want to say thank you so much for your time and attention to this. I appreciated this assignment and getting to learn this kind of hands-on end-to-end pipeline of machine learning. It was a lot of fun. Stressful, but fun. And these are some of my resources that I used for the information in this presentation. So I want to say thank you so much, and I hope you enjoyed.